So I just want to preface this video with a little statement that this is going to be a really, really boring video. Mostly because we're just going over vocabulary and definitions. Now, these vocabulary and definitions are very, very important because it allows you to understand what you're talking about when we're looking at statistics or we're looking at probability, which is ultimately statistics. So, bear with me as we go through the probability vocabulary and definitions. And I would suggest you write these down in your math notebook so that you have it somewhere that you can reference to. Okay? So, we're going to start with understanding what an outcome is. Now think to yourself, outcome. What is an outcome? And what you're probably thinking is exactly correct. And we're just going to put some math language to it to make it sound a little bit more mathy. So, an outcome is any possible or actual result of the action considered, such as rolling a 5 on a standard number cube or getting tails when flipping a coin. So, when we're thinking about probability, an outcome is anything that happens. If you have a coin that's head or tails, and you're like, okay, we're going to flip this coin, you have two outcomes. One outcome is you get a heads. Another outcome is you get a tails. Okay, so this is a result of an action that you're doing to something. So the action here is the coin. You're flipping the coin. Okay, and this result is considered when you've done the action of flipping. Okay? So let that sit in your brain for a minute. It's new language, but it will be clear as you start doing problems. Okay? The next one we're going to look at is event. Okay, an event is a desired or successful outcome or group of outcomes from an experiment, such as rolling an even number on a standard number cube. Okay, so here we go. Same thing. Let's use the heads and tails example like we did above. Okay, so we have heads, we have tails. Let's say that Billy Bob wants to flip and get tails. If he actually flips the coin and gets tails, then this is an event because it was the desired outcome, the desired or successful outcome of his experiment. If he got a heads, would that be an event? If you answered no, you're correct. Okay, but if he were to flip this coin 100 times and got 50 tails and 50 heads, he would have 50 events because he has 50 desired outcomes, which was ultimately flipping to get tails. Okay, we're going to move on. So sample space is basically all the possible outcomes. So if you think back to the problem we just did, all of the 50 tails that he flipped and the 50 heads that he flipped, that is what we call his sample space. It is all of the different and possible outcomes of the situation. Okay? Moving on, probability. This is a pretty intense definition. I'm going to read it and I want you to read along as I go. Again, remember, you can pause these videos and rewind and play again these videos so that you can really understand each of these definitions. So, probability. Probability is the likelihood that an event will occur. If you remember, an event is a desired outcome. Okay? So, probabilities may be written as fractions, decimals, or percents. An event that is guaranteed to happen has a probability of 1 or 100%. Now, why does it have a probability of both of these? Well, because 1 is the same thing as 100%. Okay? 1 whole is the same thing as 100%. And remember, those representations of numbers, they're all the same thing. An event that has no chance of happening has a probability of 0 or 0%. Okay? Events that might happen have probabilities between 0 or 1, or between 0% and 100%. So in general, the more likely an event is to happen, the greater the probability. So if I had a two-sided coin that had tails on one side and tails on the other, I would have a probability of 100% or 1 that I would flip a tails. Okay? But if I have two outcomes and I say, okay, I have tails or heads, I have a 50% chance or 50% probability of getting tails and a 50% probability of getting heads. Okay? Now, experimental probability and theoretical probability. These sound really scary, but really, if you can remember the definitions here, and you can remember these equations, you'll be good to go. Not very often do I have students memorize things because I want them to have conceptual knowledge, but when it comes down to statistics, these equations, it's good to know where they're coming from, but it's also really nice to just have them memorized. So, experimental probability is the probability based on data collected in experiments. Okay, so experiments, flipping a coin, that's an experiment. So the experimental probability equals the number of successful outcomes in an experiment, so the number of events, divided by the total number of outcomes in the experiment. So like I said, if I had done an experimental probability for flipping our coins when I got 50 tails and 50 heads, and remember I wanted tails, that was my event, I wanted to get tails. So I would have 50 successful outcomes of getting my tails over the total number of outcomes in my experiment, which was 100. Therefore, my probability is 1/2 or 50%. Moving on to theoretical probability. That's calculated based on your possible outcomes when they all have the same chance of occurring. So again, theoretical, what typically or theoretically would happen. Okay? So your theoretical probability is the number of successful outcomes or events divided by the total number of possible outcomes. So you might be wondering to yourself, how the heck are experimental probability and theoretical probability different? That's a really, really good question, and I want you to think about it for about a minute. How are experimental probability and theoretical probability different? So go ahead and keep on thinking. This is a tough one, but we can do it. So, experimental probability, theoretical probability. Ultimately, the difference between these is when you're actually taking the probability. Theoretical probability, you haven't done anything in an experiment yet. You are just guesstimating and understanding what the probability of an event happening is. So for example, if we take the coin example, before flipping a coin, what do we know, or how can we get a successful outcome? What are our chances? We can either flip a tails or flip a heads, but we know that we want to flip a tails. So the number of successful outcomes would be flipping a tails, which would be 1. We only can do that once. It's only one or the other. But how many possible outcomes can we get? 2. We can either get a heads or a tails. Okay? So you'll notice here the experimental probability and the theoretical probability in these two are the same. I'm going to go through and I'm going to look at one more example to make this a little bit more clear. Let me just erase this first. Okay. So let's think about dice. Okay, so before we even start our experiment, before we even roll a dice, we're going to try to find our theoretical probability. So we know that a dice is 6 sides. We have 6 sides of a dice. Okay, and our event, we're trying to find, or we're trying to roll, we want to roll a 1 on our 6-sided dice. So if we look here, we have our little dice. We want to roll a 1. That's our goal. Okay? But before even rolling anything, we know that the possible amount of successful outcomes is 1. I only have a 1 chance of rolling a 1. There are no other 1s on my 6-sided die. But there are a total number of 6 outcomes, because I could roll a 1, I could roll a 2, I could roll a 3, I could roll a 4, I could roll a 5, or I could roll a 6. So we know here that our probability is 16.6%, or 1/6, or 0.16. That's our probability, our theoretical probability. However, if I were to go and do the experimental probability, and I said, okay, I'm going to roll 5 times, and I rolled a 1, I rolled a 2, I rolled a 6, I rolled a 6, and I rolled a 3. Okay? So I wanted to roll a 1. Now, did I roll a 1? Yes, I rolled a 1. That was my number of successful outcomes in the experiment. I rolled 1, 1. What's the total number of outcomes in the experiment? Total number of outcomes in your experiment were 5. I only rolled 5 times. So therefore, I have 1 out of 5. My total number of outcomes is different because I'm not talking about possible outcomes. I'm just talking about what I actually did in my experiment. Okay? So moving on. This is a very difficult thing to understand, and I suggest you watch this video again if this still is unclear. Just to remember, theoretical. Okay? Theoretical probability. We haven't done anything yet. This is before we roll a die. This is before we flip a coin. Okay? It's important here. Before. Okay, our experimental probability is after. Okay? After. And that takes into account our successful outcomes or events over the number of times we did the experiment. Okay? If you understood this, be sure to like. This is very important in this video so I can get feedback. And comment if you didn't. And remember, probability's tough, but your math swag is going way up if you understand probability. See you next time.